And hey everyone, so since I'm not having you submit anything to OneNote today, I'm going to make you work a little bit more for the answers. And again, I really hope you are doing this because of our Chapter 3 test and how important this test is going to be for some of you. So I'm on page 49 in our white packet, and the problems I wanted you to look at were this page and all the way up through problem 10 on the following page. So here we go. Let's start. So we're going to solve each equation. So again, the basis of this is if there's one version of x in the problem, what we want to do is isolate the radical. So basically we're just working to get x alone like we have in the past. So I'm going to tackle, so the first three problems are set up like that. And then the other problems have more than one x appearing in them, more than one variation version of x. So that'll be a little different. So just starting with the first problem, what I'm going to do is just draw my wall. And I'm just going to start getting x alone. And again, this is just very simply just getting rid, doing the order of operations backwards. So I'll talk through the steps as I start to do them. So the first thing is the addition subtraction. I'm going to add the 1 over. And that's going to give me a 6. So I did that. Then I'll undo my multiplying and dividing, and that's 2 times. So I'll divide by 2. So I'm just left with this square root. And I'll have 3 on the other side. And now what I want to do is undo this radical. And since it's a square root, what I'll do is I will square both sides. So when I square this side, again, I'm left with x minus 3. And when I square this side, I've got 9. And now my last job is just to add 3 over, and when I'm done, I get 12. So is this an extraneous solution? So yeah, let's go ahead and just try. And I'm going to use the calculator, and I'm just going to put 12 in the left side and see if I do that, do I get 5 as my answer? All right, so typing it in. So what the calculator is going to be doing, unfortunately, it's really bright now, and it's kind of hard to see some of these things. So well, let's see. Kind of maybe see that. Hold on. All right, so I did a little adjusting on the window. So what will happen first is the calculator will do the square root of 12 minus 3, which is the square root of 9. And the square root of 9 is 3. And then it's going to take 3 times the 2 to get 6. And then it will take that 6 and subtract 1 and get 5. So since the left side does equal the other side, this does in fact work. All right, going to this. So again, I'm going to write these order of operations backwards. And this time, because we have an exponent, remember, to get rid of an exponent, and this exponent is 2/3, you will use the exponent's reciprocal, because then when I take the exponent of an exponent, or as our exponent rules calls it, the power of a power, you multiply the exponents and you'll get 6 over 6, which is 1. So that's a later step though. So I'll move my addition subtraction. I'm going to add the 4 over. And that gives me 9. And now to get rid of that exponent, that's where I will use the exponent's reciprocal. So I'll be taking this side to the 3/2 power. And that becomes the 6 over 6 as an exponent, which becomes 1. And then I don't need that exponent anymore. I don't need a first power. So it just becomes x minus 2. And then I'll take this 3/2 to the other power. And again, you have a calculator and you can type that in, and I will show you that. But it is important that you know how this happens without a calculator. So I can rewrite this as a radical. And again, the denominator becomes the little index number, and then the numerator becomes the exponent. And what will happen is I'll take the square root of 9, which is 3, and then I'll just cube that 3. So this becomes 27, and you can always type that in your calculator. You get 27. I'm going to type this in first. Whoops. Oh. Let's see. What did I do wrong? Sorry, I didn't put 9. I put my answer to the 3/2 power. Okay. Then we get 27. All right, and then from there, I'll just add 2, and we get 29. So does 29 really work? Again, you can go to your calculator, you can put 29 in, subtract 2, take my exponent of 2/3, and minus 4. So again, what's going to happen is this becomes 27, and then when you take 27 to the 2/3 power, you're going to get, let me think, 3 is 9, and then 9 take away 4 is going to give us the 5 on the other side. All right? Okay, let's go to the far right one. So again, making that list of working backwards. So here there's actually no addition, subtraction, multiplying, dividing because everything's in the parentheses. So that will happen when we get to the p. So to undo the exponent, again, this exponent is 3/2. So to get rid of it, I'll have to use the exponent of 2/3 because then my exponent can become 6/6 again, which is 1. So that's how I'm going to start this problem out. Take this to the 2/3 power and take this to the 2/3 power. So what happens is when this becomes 6/6 as an exponent, we get 1, and then they don't write a first power, they just write no power then. And then when you take 27 to the 2/3 power, again, I know you can type this in, but what's happening is the denominator becomes the index number, that little number, and the numerator becomes the exponent. And when you take the cubed root of 27, that's 3, and 3 squared, well, that becomes 9. So this whole thing becomes 9. And then I can add 3, and then I can divide by 2, and I get 6. That's not 16, that is 6. So would 6 work if I put this back in there? So 2 times 6, subtract 3, hit my exponent of 3/2. So again, I'm just typing it in, and I should be getting 27 as my answer. And I do. So far, no extraneous solutions in the first set. All right, let's check the next set. So when you have x showing up more than once, your goal is to isolate. Your goal is to start getting to the x's. So what you'll have to do in these problems is you'll need to get rid of these square roots. Okay? Now, you still want to isolate the radical first, but like this radical is already isolated. There's nothing with it. And this is just a radical, and this is just a radical. So they're isolated from each other. But like on this problem, I will have to move this x over so that it is just the radical. So there is the goal of always trying to isolate the radical. So since this one's already isolated, I can't think of the word, what I need to do is start solving for x. So I can't get to anything in here until that square root's gone. So to undo that, I'm going to square both sides. And then that just becomes x plus 11 because these cancel each other out. And then when I square this side, I need to realize that I'm squaring the whole side and that I have 2x plus 5's coming from that. And then this is just a neighbor meets the neighbor situation because, again, I don't want these parentheses. So when the neighbors start to meet the neighbors, I get an x squared. And then I get a 5x, but then I get another 5x, which makes 10x. And then when the 5 meets the 5, I get the 25. All right, so then on this side, I still have the x plus 11. And now we're going back to chapter 2. There are more than one type of x, and to solve for x, I will have to factor. So factor means it needs to be in standard form. It has to equal 0, and it needs to be in the form ax squared, then the bx, and then the c. So what I'll do is I'll subtract the x to join the 10x, which becomes 9x, and I'll subtract the 11 from the 25 to make it 14, and then the x squared will just be there. And then you can factor. So I need factors of 14. They get me to 9, and those are going to be 7 and 2. And then I can make my parentheses, my factors. And again, this neighbor is meeting this neighbor to make this all up. So when x meets x, we get the x squared. And then I draw the loops from here and from here. And I'm looking at my side numbers. So can I take x times something and make 7x, and that would be 7. And can I take x times something and make 2x, and that's 2. And then from there, you just set your factors equal to 0, and you can solve for -2 and -7. So let's see if we have any extraneous solutions here. Usually, it's very common that if you have 2 answers, there's a good chance one of them is going to be extraneous. So I'm going to try the -2 first. So on the left side, I'm going to take -2 plus 11, which is going to be 9 in there. And when I take the square root of 9, I'm going to get 3. So I just want to see if I put -2 on the right side, do I get 3? And negative 2 plus 5 is 3. So far, this is an answer. But let's check out the negative 7. So if I put negative 7 into the left side, that's going to come up with 4, and the square root of 4 is 2. And if I put negative 7 on the right side, well, then I get negative 2. So the left side's not equaling the right side, so this is not a solution. That one's called extraneous. So the next problem, again, I want the radicals isolated from each other, and they are. And now what I need to do is start to get to those x's, but I can't get to those x's until the 2 square roots are gone. So basically, I can square this side and square this side, and those square roots are gone, so you just have this, and then it becomes a really simple problem. So first I'm going to subtract the x to join the 2x, which makes it x, and then I'm going to add the 3 to the 2, so I get 5. And then we want to see, hey, is this an extraneous solution? So again, I can go to, the left side, put the 5 in, and when I do this, I'll get, sorry, you can't see that. I'll get 10 take away 3. That will be the square root of 7, which is some crazy, that's an irrational number. And then I'll put 5 in there, and when I put 5 in here, I'll get 7, also the square root of 7. So this one works. All right, let's go to the next one. So on 6 and 7, what I will have to do now is this active step of isolating the radical. So I will subtract the x over. And now this problem looks really similar to this one. So now to start getting, isolating x, I will have to undo this radical first. So I'm going to square this side, and that means I'm going to square this side, all of it. So when I square this side, I'm just left with x, and this squared means I actually have 2 of these. And then I can have the neighbors meet the neighbors. So the first neighbors meet, and I get 4. These meet, I get a negative 2x, but then I get another negative 2x, which makes a negative 4x. And when these neighbors meet, the negative and the negative, or the 2 subtractings, make a positive x squared. And again, just like before, I have more than one type of x. Back to chapter 2, I'm going to need to factor it, but first I'm going to bring this x over here so it's in standard form. So first in standard form, I do want the x squared first. And when I subtract x to over here, that becomes a minus 5x, and I'm just going to move the 4 to the end. And then I can factor. So I need factors of 4x squared that get me to negative 5x. Nice, easy factors. And now I will make the neighbors, or the factors. And again, x meets x to make x squared. And now I'm going to draw these loops. Sorry. So from here to here and here to here. So can I take x times something and make this? Yes. And can I take x times something to make this? Sure. That can be a negative 4. And then I set these equal to 0, and I solve. So real quick, which of these will work? So let's just try this one by hand. So first, if I put 4 in, I'll take 4 plus the square root of 4, and I hope to get 2. Well, I don't. I actually get 6. So this is not a solution. But if I put 1 in there, 1 plus the square root of 1, does that give me 2? Well, the square root of 1 is 1, so yes, 2 equals 2. So 1 is my only solution, and 4 is considered extraneous. All right, last one for this side. So here, what I need to do is isolate the radicals actually from each other. I need 1 on one side of the equal sign and 1 on the other. It is better to move this whole radical over to the other side by adding it, so that you just don't have anything that's negative. And I think what most people will want to do is just drop those radicals so that it's x minus 2x plus 3, but you can't do that. You've got to move the radical over first. And now I'm going to undo the radical by squaring both sides, so that we'll get rid of the check marks. And now to solve for x, this is the same type of x, so I do not need to factor. I'm going to subtract this to over here, and then I'll divide by negative 1, and when I'm done I get negative 7. So the question is, does negative 7 work? So first I'll put negative 7 in here. Oh, that's not right. What did I do? Oh, shoot. Sorry. Messed up. This is a 3. Back up. So when I'm done, I actually have -3 as my answer. So, oh well. So let's put -3 in here. And when I take 2 times -3, that's -6, and -6 plus 3 is another -3. And when I have -3 and I subtract it from itself, that's just 0, which is what I get. So this is actually an answer. Okay, don't be, like just because there's a negative number inside that square root, that whole imaginary thing, anything subtracting from itself is always 0. All right, last 3 problems. So these problems want you to find the zeros. They do mention something as complex numbers. That's going to happen on the last one, which, we haven't quite talked about, but I'll show you anyway. So finding the zeros just means I'm going to set this equal to 0. And now I'll work to get x alone. So this is like the first row of problems that we just did on the other side. So first I'm going to subtract 4. And then I'm going to divide by 2. And remember, to get rid of a 1/2 exponent, I will have to use its reciprocal, because that becomes 2 over 2, which is 1. So I'll square this side. 2 over 1 is squaring, and I'll square this side. And this side just becomes x, and -2 squared, remember, if you're going to put this in your calculator, you have to wrap that in parentheses. It just means -2 times -2, and I get 4. As far as extraneous solutions, I am going to pause on that and just get us through the rest of these. So again, find the zeros. I'll just set this equal to 0. And now I just need to isolate the x. So start moving stuff over. Subtract 6. And then I'll divide by 3. And now to get rid of a cube, I will cube all sides. So this cube undoes the cubed root, and I'm left with x plus 2, and -2 cubed, again, put that -2 in parentheses, is -2 times -2 times -2, that's -8, and then once I subtract the 2, I've isolated x, and I get my answer of -10. All right? Let's see. Finally, last one. This is kind of a throwback to the last chapter. There's more than one type of x we will try to factor, but you're going to quickly see. So find the zeros, equals 0. There are no factors of 5 that get us to 2. So since this is not factorable, we're going to do the quadratic formula where a is 1, b is 2, and c is 5. And here we go. X equals opposite b, plus or minus. Big square root, so I'm going to take b and square it, so that's 4, minus 4 times a and c, and then all of that is divided by 2a, so 2 times 1, which is 2. So here comes my x equals. What will happen in here is, we do our multiplying first, so this actually becomes 4 take away 20. And when we do that, we get -16. So this is the new part. If this were 16, I would just take the square root of 16 and get 4. But remember, when you take the square root of a negative number now, I can take the square root of 16, which is 4. But when I take the square root of a negative number, that's considered imaginary, so I put an I there. And this is a great answer. You can, if you'd like, make this simplifying triangle and divide all of these by 2. And so the better answer would be this. The denominator would be 1. The denominator would be 1, which you don't usually write a denominator of 1. So that's that final answer. This type of problem will pop up more when we get into chapter 4. But there you go. There is your homework. And yeah, there's a good amount of this on the test as well.